How will the Milky Way seem in 4.5 billion years? Many things will have changed in the universe that surrounds us in 4.5 million years. By that time, the Sun will be in its final stage of life, with only a few million years left before it becomes a red giant, and the Milky Way and Andromeda galaxies will have begun to merge to form a single galaxy. But what happens when the two galaxies collide? Will the Milky Way as we know it come to an end? Will the solar system survive the merger of galaxies? Come find out with us. Throughout history, humans have been fascinated by space and have explored the wonders of the universe using technology and science, which allows us to know what some objects looked like in the past and what they will look like in the future. This time, we must discuss our galaxy, the Milky Way. Do you want to know what changes it will go through when it combines with the Andromeda galaxy in the next 4.5 billion years? The Andromeda galaxy. The Andromeda galaxy, the Milky Way's closest neighboring galaxy, has been researched and viewed since ancient times. The Persian astronomer al-Sufi defined it as a nebula rather than a galaxy in his works in the 10th century. Charles Messier included it in his collection of celestial objects in the 18th century. The discovery that the Andromeda galaxy is a galaxy rather than a nebula was a watershed moment in our understanding of the cosmos, and it altered our worldview. This discovery, made by American astronomer Edwin Hubble in 1923, was a watershed moment in the history of astronomy. Prior to Hubble, it was thought that the Milky Way was the only galaxy in the universe and that all nebulae were a part of it. Hubble, on the other hand, was able to demonstrate that the Andromeda Nebula was a different galaxy and that there were many additional galaxies in the cosmos. Hubble arrived at this conclusion while working at the Mount Wilson Observatory in California, where he observed the Andromeda Nebula with a 100-inch telescope. Hubble discovered that stars in the galaxy differed from stars in our galaxy by studying their brightness. He determined that these stars were brighter and more conspicuous than the Milky Way stars, and that the nebulae that surrounded the galaxy were star clusters. Hubble deduced from these discoveries that the Andromeda Nebula was a distinct galaxy comparable to our own. Furthermore, he concluded that the universe had many more galaxies that were far larger and more complicated than previously assumed. This finding fundamentally altered our understanding of the cosmos, ushering in a new era of astronomical exploration and discovery. It made us understand that the Milky Way was only a small fraction of a much larger and more intricate cosmos, with much more to study and discover. An impending collision. Hubble observed that the Andromeda galaxy was heading toward the Milky Way at a speed of around 300 kilometers per second during his investigation on the galaxy in the 1920s. Astronomers were intrigued by this discovery since it implied that at that speed, both galaxies might collide in the future. However, we didn't know how long it would take because we didn't have an exact measurement of the distances between the galaxies. In his work, Hubble employed a technique known as Cepheid law, which enabled him to measure the distance to the galaxy with unprecedented precision. The Cepheid rule is based on the observation that certain stars, known as Cepheids, have a brightness period that corresponds to their intrinsic luminosity. The luminosity of a Cepheid can be measured by monitoring its brightness period, and its distance can then be calculated using the inverse square law. Hubble used this technique to calculate the distance between the Milky Way and the Andromeda galaxy, which he discovered to be about 900,000 light-years from Earth. This distance put Andromeda well beyond any estimated object, even beyond the Milky Way's edge. As a result, is regarded as an astronomical achievement. This figure, however, pales in comparison to the actual distance between the two galaxies, which is currently estimated to be more than 2.5 million light-years. Until recently, it was unknown how many years the two galaxies would collide, but that changed in 2012 when a team of astronomers led by N. Wynne Evans and Vasily Belakurov of the University of Cambridge used the Hubble Space Telescope to calculate how much time the two galaxies had before merging. The researchers found a new class of variable stars in the Andromeda galaxy using the powerful space telescope. These variable stars, known as RR Lyrae stars, are employed as distance and age indicators in the universe. Evans and Belakirov's team were able to estimate the age of the Andromeda galaxy and hence the time until the Milky Way and Andromeda galaxy combined by analyzing the number of RR Lyrae stars in the galaxy. The researchers discovered that the Andromeda galaxy is roughly the same age as the Milky Way and that the two galaxies would combine in about 4.5 billion years. As the two galaxies approach one another, they will interact gravitationally and eventually merge into a single galaxy. Other investigations have since validated and refined these time estimates by employing various astronomical approaches, such as detecting the speed and position of stars in both galaxies. In general, the calculations indicate that the merger of the Milky Way and the Andromeda galaxy is unavoidable and will occur in the far future. Milkdromeda galaxy. The Andromeda galaxy and the Milky Way will unite in around 4.5 billion years. It will take billions of years to finish this process. During this time, the two galaxies will move through space, gravitationally interacting and causing a wave-like effect in each galaxy's arms. The merging process will begin with a collision of clouds of gas and dust at the borders of galaxies, resulting in the birth of new stars. These stars will begin to form clusters and move towards the core of the galaxies. The stars will begin to orbit around the combined centers of mass of the two galaxies as the galaxies come closer to one another. Gas and dust will compress and heat up in the centers of galaxies, increasing the rate of star formation. When the galaxies merge, a new galaxy is generated as a result of the merger of the two galaxies. The resulting galaxy will have a greater number of stars and an oval shape. The Milky Way and the Andromeda galaxy are both similar in size, and when they combine, the resultant galaxy will be far larger than the original galaxies. The galaxy formed by the merging of the Milky Way and the Andromeda galaxy may be given a new name. The merging of the two galaxies is known as the Milkdromeda galaxy, however this is a tentative name that may change after the merger occurs. In any event, the scientific community will almost certainly debate and agree on a name that suitably symbolizes the new galactic structure formed by the merging of these two enormous galaxies. What will the appearance of this new galaxy be like? As the merger with the Andromeda galaxy approaches, the Milky Way will seem drastically different. The Milky Way currently has a spiral configuration with 4 major arms. When it combines with the Andromeda galaxy, the resulting new galaxy will be oval in shape, with many stars around the galaxy's center. The Milky Way's spiral arms will distort and merge with the spiral arms of the Andromeda galaxy, giving rise to a new galactic structure. The merger process will also increase the number of visible stars in the night sky. The Milky Way currently has roughly 100 billion stars, but when it combines with the Andromeda galaxy, the resulting new galaxy will have about 1 trillion stars. Because of the increased number of stars, the galaxy will appear much brighter in the night sky, and aspects of galactic structure may even be seen with the naked eye during the day. A gigantic black hole. The merging of the Milky Way with the Andromeda galaxy will have a substantial impact on their center supermassive black holes. These black holes are predicted to combine into a larger, more gigantic black hole. Both galaxies have a supermassive black hole at their cores. The one in the Milky Way is known as Sagittarius A*, while the one in the Andromeda galaxy is known as Messier 31, or M31 for short. Both black holes are massive, having masses several million times that of the Sun. When the two galaxies collide, their supermassive black holes will gravitationally pull one another, eventually merging into a single, even larger black hole. This thrilling occurrence produces gravitational waves, indicating that a disruption in the fabric of spacetime happens. LIGO, Laser Interferometer Gravitational Wave Observatory, detected gravitational waves created by the merger of two black holes more than 1 billion light-years apart in 2015. This proved that detecting gravitational waves is a useful tool for researching and comprehending the evolution of black holes and galaxy mergers. The merging of the supermassive black hole with the ensuing new galaxy may have a substantial impact on the distribution of stars and matter in the galaxy, as well as the future production of new stars and planets. These changes in the structure and composition of the galaxy could have significant ramifications for life and future evolution in the solar system and the newly formed galaxy. What will become of the solar system? The merger of the Milky Way with the Andromeda galaxy will have an impact on the solar system, which will move across the ensuing new galaxy before settling into a new orbit around the galaxy's center. What will become of the planets and Earth's life? We'll find out later. However, the merging of galaxies will introduce new stellar neighbors to our galactic neighborhood. The stellar systems in the transition zone between both galaxies will have a greater chance of gravitationally interacting with the solar system's stars. Furthermore, merging galaxies might accelerate the production of supernovae, which may affect the amount of cosmic radiation reaching Earth. The merging of the Milky Way and the Andromeda galaxy will have far-reaching consequences for the solar system. However, it is important to remember that this catastrophe will not occur for another 4.5 billion years, so there is no need to be concerned right now. The merging of the two galaxies will impact the distribution of stars and materials in the resulting galaxy, perhaps influencing the birth of new stars and planets. The solar system could be in a new part of the galaxy with altered environmental conditions, such as increased cosmic radiation or a greater population of neighboring stars. The motion of the solar system may also change as a result of the merging. If it is at the center of the resultant galaxy, it may be expelled into a more distant orbit, altering its stability and the development of planets. However, if the solar system is in a more remote part of the galaxy, it may encounter fewer gravitational perturbations during the merger. It is also important to understand that the merger of galaxies may increase the frequency of collisions between celestial objects such as stars and planets. Although the likelihood of a collision influencing the solar system is minimal, it cannot be fully ruled out, especially given the enormity of the Sun. What will happen to Earth and the rest of the solar system? Is it possible that a star may crash with the Sun? What will the sky look like now that there are so many new stars? Will the solar system be able to withstand the merger of the two galaxies? Most significantly, what will happen to the planets, the Earth, and the human species when the Milky Way and the Andromeda galaxy merge? Wait for our next video to find out the answers to those questions. What are your thoughts? Will the solar system survive the merger of the Milky Way and Andromeda? Please share your thoughts with us in the comment section.